In my last video, we talked about what AI is, machines that learn from data to make intelligent decisions. And I mentioned that most modern AI is powered by something called machine learning. But what actually is machine learning? How does it work? And what are the different types? If you watched that last video, you know that AI learns patterns from data. But today, we're going deeper. We're going to understand the engine behind AI, machine learning, and the three main ways it actually learns. By the end of this video, you'll understand not just what machine learning is, but how it works in different scenarios. Let's dive in. So what is machine learning? Think back to what we said about AI. Traditional programming is like following a recipe. You write explicit instructions. But machine learning flips that script completely. Machine learning is a method where computers learn to make decisions or predictions without being explicitly programmed for every scenario. Instead of writing if this then that rules, you give the computer examples and let it figure out the pattern. Here's the simplest way to think about it. Machine learning is like teaching by example, not by rules. Let me give you an analogy. Imagine you're teaching someone to recognize whether an email is spam or not spam. With traditional programming, you'd have to write hundreds of rules. If the email contains the word free in the subject line, it's probably spam. If it has lots of exclamation marks, it's probably spam. If it's from an unknown sender with a suspicious domain, it's probably spam. But here's the problem. Spammers are clever. They change tactics constantly. Your rules become outdated really quickly. With traditional programming, you'd have to write hundreds of rules. If the email contains the word free in the subject line, it's probably spam. If it has lots of exclamation marks, it's probably spam. If it's from an unknown sender with a suspicious domain, it's probably spam. But here's the problem. Spammers are clever. They change tactics constantly. Your rules become outdated really quickly. But with machine learning, you don't write those rules. Instead, you show the computer thousands of emails. You say, this is spam, this is not spam, this is spam, this is not spam. The computer looks at all these examples and starts to notice patterns on its own. Oh, spam emails tend to have certain characteristics. Legitimate emails have different characteristics. It learns what makes an email spam, not from your rules, but from the examples you showed it. Then, when a brand new email comes in, one it's never seen before, it can predict whether it's spam based on those learned patterns. That's machine learning in a nutshell. Learn from examples, identify patterns, make predictions about new things. That's machine learning in a nutshell. Learn from examples, identify patterns, make predictions about new things. Now here's where it gets really interesting. Machine learning isn't just one thing. There are actually three main types, and understanding these will help you understand how different AI systems work. Supervised learning is like learning with a teacher. You have labeled data, meaning you already know the correct answers. Think of it like studying for a test with answer keys. You show the computer examples where you already know the answer. This photo is a cat. This photo is a dog. This email is spam. This email is not spam. This house is worth $300,000. This house is worth $500,000. The computer learns from these labeled examples, finds the patterns, and then can predict answers for new examples it hasn't seen before. Real-world examples, think about email spam filters. You give it thousands of emails labeled spam or not spam. It learns the patterns. Then it can classify new emails or image recognition. You show it thousands of photos labeled cat or dog. It learns what makes a cat and a dog. Then it can identify cats and dogs in new photos. Or predicting house prices. You give it thousands of houses with their prices, along with information like size, location, number of bedrooms. It learns the patterns. Bigger houses in good neighborhoods tend to cost more. Then it can predict the price of a new house based on those learned patterns. The key word here is supervise because you're supervising the learning process by providing the correct answers up front. Now, unsupervised learning is the opposite. It's like exploring without a guide. You don't have labeled data, you don't know the answers, you just have a bunch of data and you want the computer to find patterns or groupings on its own. Think about it like this. Imagine you have a huge pile of customer data. Their age, what they buy, when they shop, how much they spend. You don't know what groups exist yet, but you want to understand if there are natural customer segments. Maybe there's a group of young customers who buy tech products. Maybe there's a group of older customers who buy home goods. You don't tell the computer what groups to look for. It finds them on its own by looking for patterns and similarities in the data. That's unsupervised learning. The computer looks at data, finds hidden patterns, discovers groups or structures that you didn't even know existed. Real-world examples: customer segmentation in marketing. The AI analyzes customer data and discovers groups you didn't know about. Oh, there's a group of customers who only shop on weekends and prefer premium brands. That's valuable insight you wouldn't have found with explicit rules. Or recommendation systems. When Netflix recommends shows to you, part of what it's doing is unsupervised learning, finding groups of users with similar tastes, even if those groups aren't explicitly defined, or fraud detection. The AI looks at transaction patterns and finds anomalies, transactions that don't fit normal patterns. It's discovering what's unusual, not matching against a specific list of fraud indicators. The key here is that no one is supervising the learning by providing answers. The computer finds patterns on its own. Now, reinforcement learning is different. Think of it like training a pet or teaching a game. There's no labeled data, no clear examples. Instead, the system learns through trial and error, getting feedback in the form of rewards or penalties. Here's how it works. The system tries an action. If it's good, it gets a reward, a positive signal. If it's bad, it gets a penalty, a negative signal. Over time, it learns which actions lead to rewards and adjusts its behavior accordingly. Think about learning to play chess. You don't give the computer thousands of labeled chess positions saying, this is a good move, this is a bad move. Instead, the computer plays millions of games. When it wins, that's a reward. When it loses, that's a penalty. Over time, it learns which moves tend to lead to winning and which moves lead to losing. Real-world examples: Game AI, AlphaGo, the AI that beat world champions at Go, learned through reinforcement learning. It played millions of games against itself, learning from wins and losses. Or self-driving cars. As they drive, they get feedback. Staying in your lane, that's good. Hitting the brakes too hard, that's not ideal. Avoiding an obstacle, that's good. Over time, they learn better driving behaviors through this trial and error process, or recommendation systems that learn what content keeps you engaged. The longer you watch a recommended video, the more reward the system gets. So it learns what types of content lead to engagement. The key here is the feedback loop. Try something, get feedback, adjust, try again. Just like how humans learn many skills. So we have three types: supervised learning with labeled examples, unsupervised learning finding hidden patterns, and reinforcement learning through trial and error. But here's something important. These aren't mutually exclusive. Many real-world AI systems use a combination. A self-driving car might use supervised learning to recognize traffic signs, unsupervised learning to detect unusual road conditions, and reinforcement learning to improve its driving decisions, and each type is suited for different problems. If you have labeled data and know what you're trying to predict, like is this email spam, use supervised learning. If you have data but don't know what patterns exist, like what customer groups are there, use unsupervised learning. If you're dealing with a decision-making problem where feedback comes over time, like how to win at chess, use reinforcement learning. The beauty is that all three follow the same core principle: learn from data, identify patterns, make better predictions or decisions. They just go about it in different ways depending on what kind of data and feedback you have. So why does this matter? Because understanding these three types helps you understand how different AI systems work. When you see ChatGPT, you know it likely used supervised learning with massive amounts of text data. When you see Netflix recommendations, you know it's using unsupervised learning to find user groups with similar tastes. When you see game playing AI or robots learning to walk, you know they're using reinforcement learning. But more importantly, all three types are just different approaches to the same fundamental problem. How do we get computers to learn patterns from data and make intelligent decisions? And here's what's really powerful. Once you understand this, you start seeing machine learning everywhere. Your phone's keyboard predicting your next word? Probably supervised learning. Spotify creating a playlist for you? Probably unsupervised learning finding music clusters. A robot learning to pick up objects? Probably reinforcement learning through trial and error. They're all solving the same puzzle, just with different tools. So there you have it. Machine learning, the engine behind AI, works in three main ways. Supervised learning with labeled examples and a teacher. Unsupervised learning finding hidden patterns on its own. And reinforcement learning through trial, error, and feedback. All three follow the same core principle. Learn from data, find patterns, make better predictions. Now, we've covered the three types at a high level, but each one has fascinating details we could dive into. In my next video, I'm going to explore one of these more deeply. We'll look at neural networks, which are often used in supervised learning and are the foundation for many of the AI breakthroughs we've seen recently. If that sounds interesting, subscribe and hit the notification bell so you don't miss it. If this video helped you understand machine learning better, give it a thumbs up. It really helps the channel grow. And as always, drop your questions in the comments below. What do you want to know more about? What confused you? I read every comment and I'd love to hear from you. Alright, that's it for today. And I'll see you in the next video. Thanks for watching and keep learning.